The next dryers that we have to study is freeze dryer as well as vacuum dryer. That will complete the list of equipments for us in the drying chapter, the total of 6 equipments. So we'll do freeze dryer as well as vacuum dryer in this session. The freeze dryer, the latest technology and which removes water completely. Almost 99.99% of moisture is removed from the substance using this freeze dryer, which is also called lyophilization. What is lyo? Is below freezing points. Lyophilization or freeze drying, both of them mean the same. Sometimes the equipment is called as lyophilizer or freeze dryer, right? So the two terms are interchangeably used. Lyophilization also called as freeze drying. Now, what is this freeze dryer? What is the principle involved and why is it so expensive and efficient? Is the first things first, the principle involved, main principle involved is a phenomena which is called as sublimation. What happens in sublimation is water, instead of passing into liquid phase and then converting it to vapor phase, it directly converts from the solid ice. You will freeze it, freeze dryer. The name itself says you will have to first freeze it. Water, when you freeze it, it becomes ice. Ice directly converts into vapor form uh, without passing through the liquid state. So what happens is ice, when it directly transforms into vapor form, there's less chances of water in the uh, substance. So this phenomena is called sublimation and it is the main principle involved in freeze drying. Now sublimation can take place only at pressures and temperatures below triple point of water. What is triple point of water? Is 4.579 millimeters of Hg at that pressure and at 0.0099 degrees centigrade. Triple point of water is at temperature 0.0099 degrees centigrade and pressure 4.579 millimeters of mercury. This is a point of water where all the three states happen to be uh, happen to occur. Right now, the material to be dried is first frozen. It has to become ice and then subjected under high vacuum to heat by conduction, by radiation, or both. Right? No convection takes place because there's no water involved. By conduction, you will heat. Under high vacuum, you will have to subject it to under high vacuum to conduction and radiation so that frozen liquid sublimes, leaving only non-volatile solid. The frozen liquid will undergo sublimation. What is left behind is only the non-volatile solid. Whatever is volatile will undergo sublimation. Now, what is the driving force for removal of water during freeze drying? Is the concentration gradient of water vapor between the drying substance and the condenser. Condenser, it has water vapor, more of water vapor. So the difference, concentration gradient of water vapor between the drying front and the condenser is the driving force. Now coming to construction, before we go into the parts of freeze dryer, there are 3 types of freeze dryers. Please understand that freeze dryer can be a manifold freeze dryer, or it can be a rotary freeze dryer, or it can be tray freeze dryers. Tray freeze dryers are generally used in pharmaceutical industries and it has trays, shelves for placing the substances to be dried. Rotary freeze dryers, they have a cylindrical reservoir that is rotated during drying to achieve uniform drying. Manifold freeze dryer, there is a short, usually a circular tube is there to connect multiple containers with the dried product to a condenser. I'll show you all the 3. I can show you 2 things, which is the tray freeze dryer is this. There are trays, shelves to place your product. The manifold freeze dryer is there is a cylindrical tube, a short cylindrical tube, which connects multiple containers with the dried product for undergoing freeze drying. Right. So coming back, construction, a freeze dryer usually consists of a vacuum chamber because to achieve triple point of water, you will have to get it to low pressures and low temperatures. So there's a vacuum chamber, and wherein product to be dried is kept on shelves. There are shelves or trays, and a vacuum pump is there, which has to create low pressure, and there's a refrigeration unit because temperatures have to come so low at 0.0099 degrees centigrade, almost 1 degree or 0.001 degree centigrade, right? And there's a condenser which is connected to vacuum chamber. These are the parts that are there in freeze dryer. Now, working total process occurs in many steps. Usual steps are the sample preparation. That is, you can also call it as pre-treatment. Before freezing, you will subject it to pre-treatment, right? And it is a and then comes freezing. You will have to freeze it to low temperatures. Then primary drying, secondary drying, and packaging in final product. Now, the traditional freeze drying is a complex process which requires uh, careful balancing of product, many techniques involved, etc. In this process, water is removed from a product after it is frozen and placed under a vacuum, and allowing the ice to change directly from solid to vapor state. Right? So, pre-treatment is nothing but some in freeze drying. There's a disadvantage. You cannot remove lots of moisture from the substance to be dried. So for that, what do they do is generally they subject it to vacuum drying, get it to a low concentration of moisture present in the substance, and then it is subjected to freeze drying. Right? So this is the pre-treatment. Many times the decision to pre-treat a product is based on theoretical knowledge of freeze drying and its requirements, or it is demanded. It is not compulsory pre-treatment. It is demanded by the amount of moisture present, cycle time, and the product quality. Right? Now, sample preparation is nothing but it, and by the way, it has to be completely dissolved in a liquid, in a solvent, and that solvent has to become solid. Right? And then comes your freezing stage. During freezing stage, the liquid sample is cooled down to -40 to -60. What is this -40? How do you get this? Is you have deep freezers, equipments used for deep freezing, and ice until pure crystalline ice forms from the part of the liquid, and remainder of the sample is freeze concentrated into a glassy state. In primary drying, the ice formed during this freezing is removed by sublimation under vacuum at low temperatures, leaving a highly porous structure. And this step is carried out at a temperature at a pressure of 10 power -4 to 10 power -5 atmospheric pressures, and a temperature of -45 to -20 degrees centigrade. Right? Then comes the secondary drying. This is the last step wherein most of the remaining water is dissolved. And this secondary drying takes lots of time, almost 12 to 48 hours. And it is very difficult to remove the remaining little amount of water which is there. If you remember, the equilibrium moisture content, EMC, that has to be removed is removed in the secondary drying process. Sublimation during primary drying is the result of coupled heat and mass transfer processes. And what are the last is the packaging and final product. Most of the times it is vacuum sealed. The product is vacuum sealed. Most of the times freeze drying is done in its final containers. Say I have a vial, I have to freeze dry antibiotic, which is unstable in water. So I generally put the vial, attach the vial to this, what do you call, handles, vacuum handles, and then it is vacuum sealed. Vacuum sealing is done in the packaging in the final product is done. Advantages: oxidizable substances are well protected under vacuum. Thermolabile substances are well protected. Minimal changes in the properties occur because of microbial growth. Minimal loss in the volatile chemicals and heat sensitive nutrients will happen. Very efficient sterility of the product can be achieved. And since it is highly porous, rapid reconstitution time. As soon as you put water into it, it is reconstitutes very rapidly in less than 10 seconds because of its porosity. And the final product is very porous in nature, right? And then disadvantages is most expensive unit operation, stability problems such as low temperature stress can happen, and those are its disadvantages. So this is about freeze dryer, and then we are yet to study. This is the freeze dryer that is generally there in the uh, industries. Drying chamber. There's a door. There is products on shelves, and refrigeration groups, ice condenser, vacuum pumping group, etc. All of it is there in the background, which are doing their own respective jobs. Vacuum for applying vacuum, condenser for creating the concentration gradient between the water vapor that is present in the product and water vapor here, and refrigeration for cooling. So next comes your vacuum dryer. The principle of vacuum drying is simple. Create low pressure so that at low pressure what happens is boiling point of the substances decreases. With the help of vacuum, pressure is reduced. Such low pressure is created around the substance to be boiled. So when you have low pressure, vapor pressure uh, decreases, and this reduces the boiling point of water inside the product. And hence, if you reduce the boiling point, water which dries at 60 degrees centigrade, even at 25 degrees centigrade, you will see water getting out of your substance. So when you reduce the boiling point of water inside the product, it increases the rate of evaporation significantly. What are you trying to do is thermolabile substances, the substances which cannot be boiled to 60, 70 degrees centigrade. What do you do is apply vacuum so that low vapor pressure is created. When low vapor pressure is created, boiling point decreases. 1 minute. And so the principle involved is creating vacuum to decrease the pressure below the vapor pressure of water. When you decrease the pressure below the vapor pressure of water with the help of vacuum pumps, the pressure is reduced around the substance. And when pressure is reduced, boiling point of water is reduced. When boiling point of water is reduced, rate of evaporation improves significantly. And the pressure maintained inside the vacuum drying is generally between 0.029 to 0.059 atmospheric pressure. Boiling point of water is 25 to 30. The usual boiling point of water is 100. Drying starts from 60. But here, boiling point itself is 25 to 30. So it happens somewhere between, drying starts somewhere between 15 to 20 degrees centigrade. So construction is pharmaceutical industry. Vacuum dryer is also called as vacuum oven. And they are made of stainless steel or cast iron. This thing that is shown here is made of stainless steel or cast iron, and they can bear high vacuum pressure without any kind of deformation. And the oven is divided into hollow trays. The trays are not solid, please remember they are hollow, which increases the surface area for heat conduction. Oven door is locked airtight and is connected to vacuum pump. Working, the materials to be dried are kept on trays inside the vacuum dryer. Pressure is reduced by means of a vacuum pump. Dryer door is tightly shut and steam is passed through space so that heat transfer occurs through conduction. Water vapors from the feed are sent into condenser. After drying, vacuum pump is disconnected. Dried product is collected from trays. The reduced pressure lowers the heat needed for rapid drying. Drying times are long, usually 12 to 48 hours. Heat is transferred to material as it contacts the dryer's heated surface. Now, advantages is it is usually a pre-treatment step for many of the other dryers. Before putting it into any other dryer, many of the industries put it into a vacuum dryer and then they subject it to freeze drying, FBD, fluidized bed drying, etc. And another advantage is that it is less damaging drying process. The heat sensitive substances are less damaging. And disadvantages is it is a batch type process. Cost of maintenance is comparatively high because there is a vacuum pump attached to it. And also vacuum dryers are expensive in terms of its cost. And there is requirement of skilled labor. So this is about vacuum dryer and freeze dryer.